Stellar Energy by Mariah Brown. So on slide 1, it shows how the sun emits energy or radiation to Earth. Now there's different angles on the Earth that receive different amounts of radiation. For example, A through B gets 3 radiation, while I through J gets 12 lines of radiation. As you look at the table right here, it shows all the radiation that the areas and angles get. And on the graph, the highest is G through H. So that's around the equator. Now the equator is the middle of the Earth. So it would most likely get the most energy and radiation for it stays the whole year, practically. So, yep. In slide 2, it shows HR 8799, a star in a different solar system, and our yellow star, aka our sun. So, HR 8799 will emit more energy than our regular sun, because as you see in the figure, HR 8799 has a high rating of ultraviolet light. Now, ultraviolet light is like a really dark purple light, and it will give you a horrible sunburn, for it is radiation that's really high. So our sun, aka the yellow star, emits less energy than HR 8799, because HR 8799 is a blue star. It has more energy because it's younger, while our star is a yellow star and emits less energy because it's older. Now, as you see the diagram again, our sun goes up and then down lower than HR 8799. So it symbolizes HR 8799 emits more power and radiation than our yellow star. For this reason, that is how you would get a sunburn easily from HR 8799 than from our yellow star. In slide 4, it will show an activity that we've done in class. Now I've chose the globe and flashlight activity, for it has a better understanding of the concept. As you can see, a flashlight right here shines and hits the earth right here. Now, that symbolizes day, as the darker end symbolizes night. And I took two or three photos. Now, right here you can see it's Africa. So Africa right now is in day, and right now we're in night. And as you look at the figure below, you could see that Earth tilts at a 23.5 angle. So in December, we're up higher than in June, where we're facing lower. So every time we face lower, it is summer. Every time we face higher, which we're away from the sun, it really symbolizes wet, cold winter. Now in March, we're right here on the sun. So that's more of a spring and fall. Now, I see how this helped me, because in the whole concept, it showed us how in different seasons there's different lightings. And I finally began to understand that. In this last slide, I will be answering a question. And here's what it says. Today was sure a cold winter day. As Earth orbits the sun, winter occurs when the Earth is farthest from the sun. And I am here to state that that statement is not true. For, as you see in figure 1, the Earth is in the same distance to the sun all year long, and just rotates around. Now, you can see that Earth is not staying straight up, but is tilting. That is because the Earth is not straight up like most people think, but at an angle. So, while the Earth is spinning around the sun, it is also spinning around itself. Now, that's how we get our different seasons, because, as it says, the Earth is farthest from the sun in this statement. It isn't, actually. It's the hemispheres. You see, in June, North America is closer to the sun than South America. And if you see in December, North America is farther from the sun than South America. Why is this, you may ask? Because once the angles are turning, one side of the hemisphere will be closer than the other. So that's how we get our seasons. Summer, northern hemisphere, is closer, so we're facing the sun more often. While in winter, we are farther, so we would be facing the sun less often. And spring and fall, we're right in between transitions. And that's how we get our seasons, and that's how stuff happens. Now in figure 2, you see the rotation direction of the Earth, but you also see that it has no change in direction or distance. It stays the exact same distance the whole year. This is because of the gravitational pull of the Earth. That's how it stays in one spot, but it goes in an orbitational direction the whole year. And this will conclude my statement. I've found that this statement is false, for the Earth does not move away or closer to the sun, but stays in the same orbitational distance and direction no matter what the year or time of day it is.